Hi there, welcome to the new project of time series analysis and forecasting, where we will look at the new dataset for forecasting and analyzing it within the Python. So as you must have seen my previous videos where we have looked at the different ways in which you can apply into the time series, and we will follow some of those ways into this project as well, and you will see step-by-step approach. So I recommend that you see this video right from start to end, and within this we will even discuss some of the interview question that may come when you are applying or when you are giving an interview, as well as during the business scenarios. Many times situation comes when you need to give some specific answers related to that, and we will see as and when the scenario is coming, we will be discussing it. So keep watching this till the end, and by the end give me the recommendation or suggestion in the comments about what you want to see, and what do you like in this video, what you did not like, and what I can improve upon so that I can give you a better experience going forward. All right, so without any delay, let's start this by importing the pandas as PD, importing the matlotlib.pyplot as PLT, and %matlotlib inline. So these three libraries, one of the very common libraries. I am importing pandas, as you know, for the import of data sets, and matplotlib is to basically plot the data, and this %matlotlib inline helps to plot the whatever graphics that we want to plot, like bar or line chart, within the command line just below to the execution window. Otherwise, if we don't have this, we will have to use like a pyplot.show, which is a separate command altogether, and I just want to avoid writing more and more code, but we just want to optimize this entire process with the help of %matplotlib inline. So now with this explanation, if this question is coming into an interview, you know it, why you do it. All right, so let's go ahead and start this. So what do I have is basically a very small, because it is mostly from a learning perspective. If you are here, I'm sure that you want to learn the time series analysis and forecasting. So it's always good to start with a small data set, because with this small data set you can better understand the data, as well as get a much better understanding from all the operations that we will be doing. So first of all, pd.read_csv, because it is a CSV file and it is in the same folder where this particular file is. So I'll just go ahead and simply say shampoo.csv. If this file is stored somewhere else, like for example C:// that should be capital C users/shampoo.csv, or whatever the path is, make sure you have the / when you provide it, because by default you get the / when you are in Windows. So just to make sure that you have the /. So this is the data set. You can find the instruction to get the data set within the description, and just to show you what it has is this month and sales, and this is the index number 0, 1, 2, 3, 4. So right now, if you see, the type of shampoo is the data frame, but what we need is basically a time series, right? So what we can do is another interview question: how you will import the CSV file as a time series data set. And the parameters I'm going to discuss is a very important one, so give a strong focus. I will keep suggesting you whenever there is something tricky that I'm doing, because I'm sure that it may come into the interview, or for sure they will ask you from a different angle to check your knowledge into the data import or the data manipulation process. So shampoo and pd.read_csv, shampoo.csv. So what do we need in this scenario? First is we need to keep the index as month, because once we do that, we can do a better manipulation of the data. Let's say if you want to search only for the second month. So right now it is first month 1 0 1, month 2 month 1 0 2, the second date, third date, fourth date, fifth date. So if you want to see or do a manipulation that a specific point of data frame or a range of data frame we want to see, we can do that manipulation very easily if we have the month into the index. And then we want to make sure that this is going into a series instead of data frame. So first of all, we will say index underscore column 0. This is a 0 column, and parse underscore dates equals to true. So that means what we are specifying that it is a dates column and we want it to be a proper date. And then finally the important parameter which will convert it into the time series, squeeze equals to true. So if I press shift tab, you will see all of these parameters over here. So index underscore call here, squeeze here, by default it is false, so I have kept it as true because I want that. And parse underscore dates should be somewhere, yeah, parse underscore dates is something which I mentioned as true. So if I go ahead and execute it, and now if I see shampoo, now it is pandas series instead of data frame. So that's a very important question that you will see, that how you can convert a data frame, or when you are importing the CSV file, how you can convert it directly into a time series. So the next thing after that is how you can plot it. Well, the plotting is pretty easy. Simply say plot. Pandas has these inbuilt function where by default it plots the line, and as you can see from 1st of Jan till 3rd December is something what it has been, or the March 12 what it has plotted the value. And it's a clear indication that a trend is present with some cyclical variation like this, or a bit of a seasonal variation, but a clear perspective that trend is present. Sometimes you may want to change the style a little bit, and can be an interview question that instead of line, if I let's say need to show the just the dots or the circles, so there is something which is a parameter, and you can say style equals to k dot. If I do that, this is changed into dots. So sometimes the dot representation and an easier one, and sometimes the line representation is quite easy. Default is line. If you see, we don't have specified any parameter, that's why the lining is easy. But sometimes you will see that dot, specifying or having the dots on the plot is something which is making sense. All right, so after that what we can have is basically just to know how many data points it has. So shampoo.size, so it has 36 data points, and then if we want, we can describe it, which will give us a good idea about the statistic of this data set. So this is the shampoo data set, and total 36 is the count, and that's what the count over here when we used the size method over here, and or the size property method is this. This could be a interview question. What is the difference between a method and the property? So this is a method which has the parenthesis, and it can have some arguments as well. And then we have count. Count is the count, simply count, and then the mean is basically an average. Mean, and if you see 50% is basically median, so 280. So what is the difference between a mean and median? If you don't know this, I highly recommend that you go ahead and just search it, because that's a very important interview question. What is the difference between mean and median? And in a nutshell, if I tell you, mean is simply taking all the values, summing that up and dividing by the count of value, and median is, which is 50%, median is simply the middle value in an ordered list. So first of all, you put everything in an order, and then you see what is the middle value. So suppose if you have 30th value, so 15th is your middle. So 15th, whatever the value is at 15th data point, that will be the value over here. But the important is it should be an ordered list. And then question arises, the interviewer may ask, okay, if that's the case, then what would you do? In which scenario you will use mean, and in which scenario you will use the median? And I can give you an answer, but I really want that you go ahead and search it about on Google and let me know in the comments what did you find. But that's an interview question, a tricky one. And then there is another brother or sister to mean or median, which is mode, and mode is basically the most repeated value in the column. That is also, these are basically part of a measure of central tendency, which is a statistics concept. When you read about it, the statistics, it all becomes pretty clear. So these are the values, and then it shows the standard deviation. The one standard deviation is 148, and the maximum value is 682. Ideally, you should be able to interpret all of this if you really want to be on the data science side. What is a standard deviation over here? How you would interpret 148? What does this value basically says 148 when it comes? Like I just described the mean and median, right? So now let's go ahead and first of all, one of the process that we do in the time series analysis is smoothing the time series. So smoothing of time series is basically done by calculating the moving average. So what we'll do is shampoo underscore moving average is shampoo dot rolling, and we will say window equals to. So what it means is how many first 3 values, 5 values. So for how many average values we want to take an average. I have shown this concept in my very first video on the time series. If you want, you can go back and look at that. But what it basically indicates that 5-day moving average, 6-day moving average, in that first 5 days moving average takes into the consideration, and on the 5th day you get a 1 value. So that means the first 4 value basically gone, and then the value is basically starting from the 5th day. So right now I just take 10 and then I want average. If I do that and if I plot this, you see that it is very smooth, and some of the initial data point has gone and the value is starting from 111 because I used the window equals to 10. So the first couple of values up until 9 the value has gone. So from 10th it will be starting, 11 is here, 12, 13, and then so on and so forth. If you see, this is a very smooth series as compared to this one. So just to understand whether this series is following any trend, if it is not very clearly visible, you use the moving average over here. And moving average very highly used into the stock market analyst as well as in some business studies as well. But stock market analyst is the one area where I have seen that this moving average is being used a lot. Okay, so with that, what we can do now is create a baseline model. So this is just for the representation, that how you create a moving average, which is also an interview question, and the interview question is also about the window size that you need to basically have, and what is the downside of having the large window size. So I have explained that entire thing to you. Now what I want is simply the creation of baseline model. So what is a baseline model? So if I just say shampoo, right? So what baseline model really helps in the time series, and it is an interview question, that what is a baseline model. If or what is a naive model, which is, or what is a starting model. All of these are like common terms, that baseline, naive, or initial model, which is like defining your baseline. Below this, if there is any model, just remove that. So the first model is like no brainer. I mean, anybody who does not even know about data science should be able to do it. And the method behind, or the assumption behind that, is that the previous value, which is this in this case, previous value is the best reflector of the next value. So for 260, for 2nd January, so this is the 2nd Jan, this is the 1st Jan. For 2nd January, the best reflector or the best prediction as per the naive model or the initial model is the previous value. So for 2nd, it will be 266. For 3rd, it will be 145. For 4th, it will be 3rd. So what it basically assumes that the previous values are related to the current value. So what we have observed last day will going to reflect also in the current day with some more variation. And with this assumption into the time series, we go ahead and create the naive model. So to do that, what I need to use is basically the shift method. Shift method helps to shift the data points 1 point down, right? So what I do is shampoo underscore base equals to, I will use some method, I will explain you, pd.concat, because I am not going ahead and creating a separate column altogether using a common technique, but I'm just creating, I'm concatenating as well as creating, which is a process, little advanced process than following it very step by step. So what I'm saying is I need shampoo in this. Shampoo is one column or the one series, and shampoo dot shift by 1. That means put the shift down and axis equals to 1. So if I execute this, you will see that shampoo underscore base is this. Sales 266, but for forecast it will be here 266. 145 is here, 183 is here. So the structure of our baseline model is created, or the naive model is created. However, if you know that you should not have this particular value, which is a missing value in this case, it gives an error when you evaluate the error metric. So whenever we produce model, we need to remove these values, and before that we need to give the names to these two, right? So we need to rename the column. So how you rename the column? Again, for beginners, it is an interview question related to the data manipulation. So shampoo dot base columns, what happens when you execute this? It gives you the column names like this. So what I'm doing is I'm following the same methodology, equals to, within the bracket I will just specify the new name over here. That is it, saying actual sales. So just to make you very simple that what I'm doing and how it is reflecting. So this is what the representation it needs, and that's the representation I have given over here. If I execute this and again say shampoo underscore base dot hat, so actual sales, forecast sales. Alright, so now we have renamed the column. The next thing is dropping this value, and to do that the method is, remember this comes very frequently, drop NA. If you do that, if I do that, what happens? Value is dropped, right? But there is a catch over here. First of all, remember the method drop NA. Drop NA is the method that you use to drop the NaN or the missing values wherever it presents. So it removes the entire row if you see. But if you see shampoo underscore base, the problem is the missing value has come back, right? So what you need is basically a parameter over here in this method, which is in place equals to true. So this makes sure that whatever changes is basically dropping the NA value. is saved or as become part of the data set. So if I execute this, and now I am here, shampoo base, if you see, the value is removed. If you want to check it again in a new column, shampoo underscore base dot head, you don't have that value. So this way you make sure that you have the proper parameters and everything present over here, which is responsible for making sure that your data set is properly made for the baseline model. Now let's go ahead and import the mean squared error metric and the numpy array for the calculation of error between the actual and forecast sales. So from sklearn dot matrix import mean squared squar squared error and then import numpy as np. So why? Mean squared error simply gives us the mean squared error, but the problem is it is squared, so it cannot be, we cannot interpret it in the same term. So to remove the square, what we need to use is np.sqrt, the square root method, which will keep it in the form which is similar to this value or in the same matrix system in which this value is being calculated. So let's go ahead and execute this, and after that we have shampoo underscore error mean squared error shampoo base dot actual sales shampoo base dot forecast sales, right? So if we see shampoo error, so the value is 11715, which is definitely not anywhere related to the matrix system that this particular data set follows. It may be in thousands or it may be in millions, who knows, but this is definitely not following this. So what we need is np.sqrt and then the shampoo error, and this is like 108. So now the value, you can relate it with this particular metric which is in the similar lines. So 108 maybe in the thousands or the millions, you can interpret it as per the metric that your data is following. All right, so that's now what we can do is we can create different types of models. For example, there is a moving average model, there is an autoregressive model, there is differencing that you can do to make the series stationary and whatnot. So, but at the end of the day, if you will see, most of the practitioner, the real time, those who really work, basically use the ARIMA method, which is autoregressive integrated moving average. So it contains everything. It contains autoregressive, it is integrated, it is moving average. All of that is part of one single model. So I just don't want to use and make this video very long, but just want to make it concise so that we focus on the main topic, which is ARIMA. And within ARIMA, if you say you can create an autoregressive model, how? You just specify the term or the parameter for AR, which I'll show you. For example, ARIMA is like this: P, D, and Q. So in this, you have P, the parameter P is nothing but the autoregressive. So let's say if we have the model ARIMA 2, 0, 0, that means only the P term is specified, so it is an autoregressive model. So why should I go ahead and create a separate autoregressive model? Or if I say 0, 0, 2, then it is a MA model, moving average model, because we are not considering the last two. So if you are a very experienced practitioner and coming into the Python, this is the way you can do it. You don't have to experiment and know a lot of different values. Within the ARIMA, you can basically create either autoregressive or the moving average or a combination of everything, which I will going to do in just a couple of minutes. So autoregressive is we need to calculate the autoregressive and the moving average term by having the ACF and PACF. So just remember, PACF is to evaluate the parameter for P, which is autoregressive, and ACF curve is for moving average. Okay, so let's go ahead and first of all get the stats models dot graphics dot TSA plots, import plot underscore ACF and plot underscore PACF. So from this term, just remember PACF is for P, and then next another one which is without P is for Q. That's how I remember it. If it is confusing like ACF and the PACF. All right, PACF. I mentioned PAFC. That's why it gave the error. Right. So what I'll do is plot underscore ACF to see the Q term, and that is shampoo dataset. I'm picking up the entire dataset that I created previously, but not from the base model. So what it has is basically at the term 0, that means this value is equal to this value. That's what 0 basically mean. Or if I just go back just for a better in view for you, sorry about that. What it basically has at 0 term is 266 equals to 266. Then what is the correlation between them? And at the 1 term, what is the correlation between these two? So that's what it basically calculates, the correlation with the existing, the one previous term, the second previous term, the third previous term. So over here it shows that the third previous term, the correlation is going below the range or the critical range. So when up till what value you have out of this critical range, you consider that. And so for in this case, the Q will be the 3, 0, 1, 2, 3. So Q or Q is hash Q is 3 is something what we figured it out. Now what I do is plot underscore PACF and shampoo, and in this case after the second term 0, 1, 2. So you have P as 2. Now what we need is basically differencing term D to make the series stationary. Sorry. Alright, so usually it is between 0 to 2. Okay, so we will experiment it between 0 to 2. Maybe 1 is sufficient, but we can even try it with 2. Okay, so what it does is make the series stationary by removing the trend and the seasonality factor, which helps us in doing the better prediction. Alright, so now let's go ahead and import the ARIMA model from the stats model. So from stats models dot TSA time series analysis dot ARIMA underscore model, what you have is ARIMA. Execute this, and I'll just create the train and test. So train is shampoo 0 to 25 and shampoo score test is basically shampoo 25 to 36. So it will take the value from 0 to 24, and you need to tell me why, because this is an interview question and I already explained in one of my previous video if you have not followed it. So if you're not followed it, go ahead and see that. What I just wanted to complete the sentence. Alright, so first 24 values I have taken over here, rest of the values in this, and if I execute, sorry, TEST, if I go ahead and execute this, you get the train and test dataset. So I'll just create the model, which is ARIMA using the train. So train and test, why we create it, if that's what it is going in your mind, just to make sure that when we evaluate our model, we have some unseen data which we are keeping it in the test for the calculation of error metric, which is a best practice. So shampoo underscore train order is what we need to specify. 2 1 3. Let's try with that. Sometimes it gives error, but not an issue. 2 1 3. So it's just a warning. For now we can just go ahead and ignore that. And now what we have is the shampoo model. We need to fit it. That's a part of the process. Once the model is created, you need to fit using the shampoo underscore model dot fit. You should include invertibility, choose a different model order. So it's not allowing you to use this particular model. So what I'll do is I'll use 313. No, 312. Let me try that. Yeah, in that case it has worked. So it gives based on how ARIMA's dependencies are on the model creation. When you fit the data, it basically gives a warning, like in this case, which says that whatever order that we have specified is not consistent. We need to have the consistency. So generally in the case of ARIMA, we need to make sure that we specify or experiment with couple of orders to get the right fit. Okay, and I will tell you the model tuning also, which is an automated way of doing the things. So don't worry about this. All right. So once we have this, we can have the the forecast. So shampoo underscore forecast. And before I do the forecast, I'll just tell you one more thing, which is archaic information criteria, which is used to see how good the model is once you fit it, and lesser the value, better the model. Shampoo underscore model fit dot AIC 272. Not an issue. We'll just go ahead and test it. So now shampoo underscore forecast, that means create the error metric. Forecast equals to shampoo model fit dot forecast, and steps equals to so we took 0 to 25, and that should be the next 11 values if I'm not wrong, and 0. All right, so it has created. So 0 is basically contains the actual forecast value. It has like 2-3 different arrays which has like residuals and couple of other things. So what we can do is now np.sqrt, just to take the square root of the mean squared error. I explained you already about this. Shampoo underscore test, shampoo underscore forecast. So first you will see the observed values or the unseen values, and then forecast value. If I go ahead and execute this, what I get is the 130 is the error rate. So 130, which I got as part of the error that this ARIMA model contains, I need to test it against my baseline model, whether this model is better than the baseline model. If it is not, I will not accept this. If it is better than the ARIMA that model, then I will accept that. So over here, if you see, the error is around 108. So even the baseline model is working much better than the ARIMA method over here. So that shows that our baseline model is much better when it comes to doing the prediction than our ARIMA model, right? Because the value that we got is 130, and value where here we got is 108, where it is 108. Okay, so this way you basically identifies whether you can accept the model or don't. Obviously you can tune the parameters and all, and which is basically the next thing which I can tell you. So what I need to do is in that case is we need to specify p underscore values equals to range. In which range we want to evaluate the p value? That means 0, 1, 2, 3, 4. What is that value? So let's say we want to experiment between 0 to 5. The values between the range 0 to 3, and q values we want to experiment between 0 to 5. Okay, let's go ahead and execute it. And before I go ahead and execute this, what I need is basically I want to import the warning, because this process will show a lot of warnings. So import warnings, and warnings dot filter warning, say ignore. This is a method if you want to ignore the warnings which are coming, like this one. Okay, all right. So what I need is basically a loop where I can loop through these values. So for p in p values, this I have already done in one of my previous video. I'm just doing it again, and I have explained it in a long detail that I am just iterating over PD and Q value in the same order in which they go into the order parameter of the ARIMA method. So P, T, Q. So this P is coming over here. So first the P is going, so 0, and then this particular, the iteration will happen, and you will see the iteration also. So for now, I'll just go ahead and say train and test, and simply what I did earlier, shampoo 0 to 25 and comma shampoo 25 to 36, and then predictions equals to list. I want to store the prediction in a list so that I can test it in the using the test, and I need to loop through number of times the test is basically there. So for I in range of alien test, right? Because that's the number of times we have the values into the prediction and we want to store it. So we need to loop it through by that number of times. So it is 0 to 11 in that case. And we want to just, in case of an error, so you've seen that error has come earlier. We want to just continue when the error is coming, and warnings will be removed in that case because we have already filtered the warnings. ARIMA and train order model underscore fit equals to model dot fit disp equals to 0. I have already explained in my initial video about this particular displacement. And then pred underscore y equals to model dot model underscore fit dot forecast. Want to get the forecast value which is stored in the first array, and then we say predictions dot append the predicted value which we just did in the above statement, and then finally what we have is the error which is mean squared error, and say test predictions and then we can print it the ARIMA %s because it is a string RMSE equals to up till 2 float value we want, right? And where it has gone, percentage specify the order. This is the order that we had order. What is the order that we are following right now, and what is the error? Okay, you can even have colon if you want, or if you don't want, that's also okay. And then finally for try we say accept, continue. So we have just completed this model. I hope it should work fine, and if I execute it, yes, so without any issue it is, if you can see 000 001 which is Q, 002 003, right? and then 010, 011 and all of that. It's basically going on and showing you the different errors. So what we can take is this is not the RMSE route, this is just the MSE, sorry, just the MSE. So next time whenever you run, say MSE, not RMSE. I may be experimenting with earlier. So RMSE is something which we will try. So right now the smallest value we have got is 188845, and if I just say calc 18845 and I take a square root of that, we get 137, and 137 is even higher than 130, which is even higher than our naive model. So our naive model is still winning, right? And it will take a minute, so I'll just pause the video. Alright, so it has been completed. It took some time, but like for example around 2.5 minutes to complete all the iteration. And if you see, if I just scan it through, though there is a process that you can just have the minimum the MIN parameter to get the minimum value of the error. But for now, what I have is I can quickly scan through as I was watching it. 14492. Is there anything smaller than this? No. So this model 323 is our best model. So let's see whether this is smaller than the naive or not. 14492. Take a square, 120, and 120 is the error that we get in case of ARIMA 323. So 120, if I say 120, over here it is 130, so it's better, right? Our previous ARIMA method. And if I say the naive, where is our 108? So this model, even this model, which we have tuned it through the parameter, it is 120 if you see, and still not better than the naive model. So we will going to reject it, and we will just keep the naive model unless we find another better model, and that requires, let's say, the log transformation or another types of transformations that one can apply and figure it out the right value. Or maybe you want to furthermore experiment it with the moving averages and couple of other things. But what I mainly wanted to talk about is basically how you can create naive model, the ARIMA model by your hand by evaluating ACF, PCF, and finally the code which will help you the figuring out all the different types of parameters which is required, which if you see, this entire process would require to do a lot of permutation combination in terms of trying these different parameters, but this simple script really helps you to evaluate this entire thing. So that's about it. Let me know, how do you see this video? What you like, what you did not like, and the things you want me to continue to do or improve upon, and that will be really amazing to see your comments in the comment section. And yeah, till then, thank you so much, and don't forget to share it with your friends and colleagues.